here's the question we're going to be taking a look at today, which is worth 30 marks. We're given a coordinate diagram showing parts of the town where Ben lives. In part A, we're told that Ben's bike is halfway between the shop and the school. From this information, we have to plot a point on the diagram to show where Ben's bike is. So to start off, we can join the shop to the school by a straight line, and from here you can see that the distance from the shop to the school is 4 diagonal squares. So therefore the halfway point between them would be 2 diagonal squares. So this is the point B where Ben's bike is. Another way to do this is to use the midpoint formula, which is given in your logbooks and says that to find the x coordinate, you take x1 plus x2 over 2, and to find the y coordinate, you take y1 plus y2 over 2. Taking the coordinates of the shop to be x1 and y1, and the coordinates of the school to be x2 and y2, we find that the midpoint is -1, 3, which is the same answer we got using the other method. Moving on to part B, we have to work out the distance from home to the shop on the diagram, giving our answer correct to 1 decimal place. To solve this, we can use the formula from our logbooks to work out the distance between 2 points, which is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. Looking at the diagram, the coordinates of his home are 3, 3, and the coordinates of the shop are -3, 1. So these are our 2 points. We'll let the coordinates of the shop be x1 and y1, and the coordinates of his home be x2 and y2. We'll call the distance between them d, and fill our points into the formula. When we do this, our equation becomes d is equal to the square root of 6 squared plus 2 squared, which is equal to the square root of 36 plus 4, which is equal to the square root of 40. And that's equal to 6.3 centimeters, correct to 1 decimal place. In part C, we're told that each small square in the grid has sides of length 1 centimeter. We're then told that the distance on the diagram from the shop to the school is roughly 5.7 centimeters, and this is to a scale of 1 is to 2,500. So we have to work out the actual distance from the shop to the school. So that's a lot of information, so let's break it down bit by bit. Our scale is 1 to 2,500, and we have to work out what 5.7 centimeters is, so we can multiply the left hand side by 5.7, which means we also have to multiply the right hand side by 5.7 as well. This gives us the new ratio 5.7 is to 14,250. So this means that 5.7 centimeters on the diagram is 14,250 centimeters in real life. And to convert this from centimeters to meters, we divide it by 100, which gives us an answer of 142.5 meters. In part D, we have to show that the slope of the line from the shop to home is 1/3. To work this out, we need to use the slope formula from our logbooks, which says that m is equal to y2 minus y1 over x2 minus x1, or rise over run. And we already worked out the coordinates of these points back in part B, so we can use them again here. In this case, we get the equation m is equal to 3 minus 1 over 3 minus -3. And that works out to be 2/6, which can be simplified to 1/3. Finally, in part E, we're told that h is an angle such that tan h is equal to 1/3. We have to use this fact to work out the size of the angle h correct to the nearest degree. So the equation we're given is tan h is equal to 1/3, and so to find the size of h, we get the tan inverse of each side. So therefore h is equal to the tan inverse of 1/3, and when you put this into your calculator, you get an answer of 18.4349, which is 18 degrees, correct to the nearest degree. And that's the end of this tricky question. This was really complicated, so I hope you understood everything. Thanks for watching, and I'll see you again.